Okay. Okay, so now you should see me, hopefully. Yes, okay, I didn't press the stuff. I'm still learning, I'm getting confused and I did the stuff. So I think is, let's wait a little bit more here. You are the only one, I think, right now. If you have any questions, feel free to ask. I will try to answer them. I'm trying to log in my... Hi, Divisor. We're going to wait a little bit here, and I'm trying to get my stuff. Well, actually, I don't need that. I see you guys here. Okay, so I did a little overview last time. Layer using Axum. Okay, that's cool. We can do that. So I think there were 5 people that wanted to talk about the Rust web app. And it's great because actually this year I'm going to spend quite a bit of time on it. So it's perfect. So I think I answered you. Can you repeat the question here? I might have missed it on, I mean, I don't remember which one it was on Discord. Okay, so today what we're going to do is kind of an overview of, if nobody is asking question, I'm going to do an overview of the Rust web app and the code and the architecture and all of that. And then the OAuth one. Yeah, you wanted to have the OAuth implementation kind of things. Is that correct? I think that is what you meant. On the stuff. So I think is for the OAuth. Yes, okay. So let me share my screen. Hopefully you see my screen here, which is going to be, we're going to do like that. Yeah, everybody can see it, okay. So at the top level here, the Rust web app is, so this is kind of a visualization of the request flow, basically. And all of this, in a way, they are Axum routes, okay? And there's a static one here where we go and we just use a static, whatever the default static they have. We have the API login, log off. So that is not part of the RPC because in a way you want to be able to call it when you are not logged in or even not logged off. And so like this, you can have different routes for these two. And then the things that I like is JSON-RPC. And the reason why is because most of the time when we do an application, it's mostly about request procedure call on the client. Yeah? So we want to list something and everything. And so the gymnastic of trying to have to resource code it's a little bit of gymnastics that is not really needed in many ways. We can say post is for create, push, update or whatever, or patch is for patching, and then so on, and get is for get and things. But then when we do a get and a list, we want to have filters, but because it's a get, we cannot have body, so we put everything in the arg. But then if we want to have a lot of filters, then it gets tricky. So then after we serialize a JSON, the parameters, and it gets very cumbersome. rather than just having an RPC model where we can say, you know, user list or project list, project underscore create or whatever. So that is what we're using, and this is what we have there. The question, I'm going to answer the question here about the authentication. Yeah, so in the login, okay, we'll talk about this one later about the job. I'm going to finish about the login and the OAuth. The login here, we do the login and the logoff, and that will create, when you do a login, that will create a token back to the UI. And the token here, if we go, this is this kind of architecture here that we have there. And so that is when we do a login, so that is, yeah, that should be the login. Sorry. Okay, so that is a login, yeah, the API login. And then when we go to the API login, we go to the username password in clear. And then on the backend, we do this user BMC, first user, and then we get this data. This data is what is needed to, one, check the password. So we replay whatever scheme we have to hash the password to make sure that it's the same guy. And then we have the token salt, because the goal is to create the token to send it back. Yeah, so that is the goal of the login. Now, with the OAuth, it's a completely different thing. Yeah? That is logging to your own application. With the OAuth, and at some point I will add it to Rust Web App, but it's almost another endpoint. So what I will do here is I will have another guy here, not RPC, another branch here, that will be OAuth in a way. And the goal of the OAuth, the way it works is user gives username, password to someone else, and then there's a ping pong that is happening that is sending us back the content. So that is the thing here, which allows us to, with this endpoint here, we'll make sure that we can get it, get the code from the URL, and then we'll create the token to get back to the user. So in a way, the API OAuth, or whatever we want to call it, or it could be endpoint OAuth, or whatever you want, because it's not really an API, yes, you get back from the end user. So I will say, I wouldn't put API, I will put something else, OAuth redirect, or whatever we want to call it. And basically what that will do, it wouldn't need this guy, it will do the flow. Once he gets it, he gets the user, and then he will go the flow, sorry. No, okay. It will do, sorry about this. It will do this flow. So here, it will get a user for auth, and then it will have the token salt, and then it will create the same token here. So then we are back to this format, back to the UI. So we get the code or whatever, we can get the token. We might want to store the token on the server side if it's a token we want to use to access Google or whatever. But then after, the token we send back to the user is the one we own. So we don't care about JWT or whatever that people are using. We are appropriating ourselves our own token, and we send it to the client. So hopefully that makes sense to most. Yeah, does that make sense what I'm saying, or any other questions? Okay, so I'm going to assume it makes sense. Now, there's a question here. How will we... Okay, cool. How will you handle allowing concurrency for certain queues and not others? Or will you keep the token? That is a good question. So this token here again is stateless. Yeah, so the whole architecture here is when it comes and we do the auth kind of stuff, we don't, we do get username, but we ask this guy and we just create the token back. Yeah, so we don't do that when we don't need to log in. We just have the user ID as part of, I mean, we get the token, and from the token, we get the user ID for auth, and then we do that. Now, in a OAuth kind of scenario, will I keep the OAuth token, whatever Google or GitHub sent us? And the answer is probably yes in a database somewhere, but it's independent of this flow, of this authentication flow. It's part of the OAuth, and then we keep it because some of these services, sometimes you want to do an OAuth to be able to get data back from the server. So in this case, we want to make sure that we reuse the token that we got. So you store it in the database, and then you store it, and then you might have to handle the refresh token or whatever. But you store that in the database such as the user can access their Google stuff. So hopefully that answers the question. And by the way, when I answer a question, if you can say, okay, got it, this is good, so like this I can move it, but otherwise no big deal. The other one is, how will you handle allowing concurrency for certain queues and not others? So that is a very interesting question. And one that make me ask more questions. When you say queues, what is the example of queues you are talking about here? I'm not really sure. I get what kind of queues are we talking about. So while you add the chat here, because I don't see it in the chat yet, but there's a couple of things. Usually when we do this kind of request flow, for me, a web app server shouldn't take more than a sub-second to answer. So there is no asynchronous work to, even if you call asynchronous, it's not the place to do a long-lived stuff that will take a minute or two, or even 10 seconds or 20 seconds or whatever. So if you have a processing that take a little bit longer, the exception is, for example, when you upload a file, let's say that you have an application where you need to upload a file, where there's many ways of doing that. You can go directly to S3 or whatever, but if you say, okay, I'm going to take the files on my middle tier, and then I will put it at the right place over there, that will take longer, and in a way we hold the user. But for any other things, usually you want your web server to be in a sub-second answer stuff, and to put the jobs that will take things that will take longer in backend services. Okay, so that is the way I will architect stuff. And the way here that in production we do that, yes, so the question was relating to the long-running services that may be executed by a service. Can you give me an example, for example? So while you are giving the example, the reason why I'm asking the question in my head is because in my case, the long-running services will be here. Yeah, those are the long-running services. These guys, they don't have long-running services. These guys, they take a request, and their goal is to get the data somewhere and to respond to the request. Yes. So let's take an example here. For example, an application that we created in the medical space. We created a Surgeon platform in the medical place, and so it was pretty involved. And we were downloading videos from S3 box or whatever. And then we had to go a service to frame them, to do a 2 frames per second, for example. And then we were uploading them, we were scaling them to make sure that we had 1080p, 480p, 780p, 720, and so on. And then we had other processes to extract metadata or whatever. And so usually those services to, like, for example, even import things from an S3 or box node. That was a service which was the importer, for example. And then we can have a service which is a scaler. The goal of the scaler is get a message queue here from the message queue. So this guy imports the videos, and then he sends a data event and say, hey, I imported a new video now. There's this new video there. And then service 2 was listening to new video guys, and say, oh, there's a new video. Okay, I'm going to create a job for myself. So we have this concept of self-feeding jobs. So these jobs were able to listen events and creating job for itself. And that is very important to be able to scale those guys. And so then after, the service 2, which was a scaler, was like, oh, do you have a new to-do for me? And then it took the to-do and said, okay, I'm going to download these big videos or whatever, and I'm going to scale it to 480p, for example. Yeah. And then when it was done, it was sending an event here to say, hey, there's a 480p ready there. And then who knows, there might be another service here that say, okay, when there's 480p, I need to create a zip file with all of the images. Yeah, and for later for AI or whatever, yeah, or 2 frames per second or whatever. So that was the way it was working, yes, is all of the services were sending data events to the queue and then reading data events from the queue and then sending that like that. Does that answer your question? So that is a way that we put long running processes, not in the web app server, behind the scene. Does that answer the question or not? So I guess it will. The question was related to a long run. Yeah, okay, cool. Imagine there's a certain type get trigger. So, okay, so I answer the stuff. So the trick here, and so I think that, and we're going to have in the live, and I'm going to make videos. I'm doing a video that you might have seen already as an early preview. Now, as soon as I have a video, I publish it to the members. It will go live, I think, on Sunday. And it's about the server and serverless and all these kind of things. Yeah, so those guys could be serverless sometime, perhaps. Or they could be pod. It doesn't really matter. The goal is to be event-based. So that is the key here. Once you are event-based, then services Lambda or pods meaning container image, Kubernetes Manager or ECS, or even Fargate, then it scales well. Yeah, so that is the way it does. Will you monitor the queue? This is so. One thing I love about one technology I love about the queue is Redis Stream, which is now I'm going to call it the Valkey Stream. Okay, I'm a big fan of the Valkey project, which is a fork of Redis, fully open source, truly open source, and they still have the stream in it. And one of the amazing thing of the stream kind of things, and I have a very dirty architecture, I think, somewhere there. This one needs to be cleaned up, but the thing is, you have a stream which is a kind of a queue, and then you have a thing that does the X add, and that add to the queue, and you can add as much as you want. And then you have these kind of core things that are called work group, and a work group is kind of a window of this queue, and you can have multiple consumers of this group. So those will be pod in my case. So in my case over there, oops, sorry, that will be this guy. The service will be a work group, so I can have 10, 20 or whatever. I can scale them with AWS, with EKS or whatever. And then those guys will be part of the same work group. So they listen this queue with this work group business. So they will only take one. So when C1 takes this one, and then C1 can take this one, and then C2 can take this guy, for example. Yeah, so that would be an example here. And there's some pending list and things and all these kind of things that you can query after. So for us, we use a lot Redis Stream because it has this, and it's very scalable. Even if single-threaded, sometimes people focus on the single-threaded nature, but except if you do 4 kilohertz events, you won't run out of this guy. Yeah, moreover, if you have long-running job, like a minute or 2 minutes or 3, but the nature of the system, that will always scale better, more than all your job combined in a way. It's super efficient, and it's super memory efficient as well. So the point of this here is that now people, when they query it, is for the work group, there's only, every item get only taken once. So now you can do stuff. And so that means that, for example, we can have So I have some example here. We have data main or like the frame, a stream like that. And then multiple people can listen to this stream. Yeah. And then they can have work group to do different type of work on the same stream. So that is a very efficient way of doing it. And then you will monitor. So then if you want to monitor and keep track of this queue, sometime what we do is when the worker start or whatever, then it updates the database. Yeah, so we use the Redis stream, Valkey stream, as a memory, a live, very efficient real-time notification in a way. But that doesn't prevent us to say, hey, for this kind of jobs or this kind of things, we're going to also store when it gets started, when it gets ended and stuff. Then when it gets picked up, it gets stored into the database. Yeah. Now, the challenge of this approach here, of any approach of stuff, is what happens if one of the jobs crashes? Yeah, so either the pod crash, so either one of these pod here crash, or the job itself crash or whatever. Yeah, so with Redis, you can look at pending and things that hasn't been acknowledged and so on. And so you have to build extra logic. But once you have that, you have a very scalable system and very resilient, because what you build into those things is to say, if it crashes, it doesn't matter. It's part of the normal workflow. If it crashes, then the job somehow, you have to obviously cut that, but will get put back into the queue, and then it will get picked up later. So this way, if you have a bad pod or whatever that crash or whatever, it doesn't really matter because the job is bad. And then you can implement in your system, the number of retries, such as you don't retry too many times the same thing, because sometimes it crashes because of data. So it will be kind of silly to keep trying. So sometimes you have to take it offline and then understand why it didn't work. Does that make sense? So now, if I go and look a little bit at the source code here, what we have it's not a web app. I'm using Sketch app. So I have a whole workflow on Sketch app where I create the icons and I can do live development. One day I will look at it. I think I showed it in Awesome App, I think. So I have some utilities that I implemented. Some of them are still in Node.js. Usually I re-implement everything in Rust, but some are still in Node, that allows to extract icons from Sketch, and then I do all my slide, all my presentation, everything in Sketch. So it's my go-to. So one of the things here, let me make it the friendly way. And this is a thing here. In the video of 4 hours, we talk about it. And but one thing I'm going to do more and more is, talk about all these kind of things as well in the live and other videos, because obviously not everybody has followed the 4 hours videos. But the point here is that we have all these libs over there, as you can see, and then we have the services. Right now, I have only one service, which is one server, okay? And then I also have the tools, because I like to write my tools in Rust, because Rust is awesome. Now, if the way that maps to the production things is that our web server here is this guy. And sometime in production, what you want to say, okay, I'm going to have this guy with server A, and that will be my web server. I mean, I'm calling it web server, which is the standard one. But I might have an IT server, which doesn't have to scale as much, by the way. So often the IT server is to say, well, the IT server is going to be our company server to manage organization, debug things and things that we don't want to pollute the common web application. Yeah, because sometimes you want to have this super user that can access everything and all of that. So there's a need sometimes of different web servers. And sometimes you have the need also of different web services. So this whole architecture here, which is what I call a Kubernetes driven, because the beauty of it is all of that can be deployed on your local machine. And you can run the whole system in your local. And that is a beauty thing, yeah, because beautiful thing, because you have a lot of companies that every time a developer comes in, they have a cloud environment and all this mess because everything is cloud and everything. And the problem of that is bills add up. And then you end up buying with teams that cost $1 million a year or crazy stuff. And also it's not that efficient because doing sub-second development in a cloud, the nature of things is not really designed for that or friendly to that. And so it's get very tricky. If you have everything on your local here, you have all the services. We are using Valkey Ready Stream, and that can be very efficient. And so you can deploy that locally and then debug your stuff, and then it's just Kubernetes, and then you can put that in the cloud. And even for the cloud storage here, the S3, we use Min.io, which have a great mock of S3. So like this, we can even mock that. Now, for the big data, for the projects that we're using Google Big Data and stuff, that is not something you can have locally. It wouldn't really make sense to mock it. So what we do is we have a big data for development. And then with Kubernetes, we point to that. And then we have a namespace, such as we make sure that developer has their own space, and then that's it. But even the Cloud SQL, the Postgres, for example, that will go to the Postgres when it's developed on dev locally. And even when it's deployed on dev, we have dev and stage on production as well. We put that in a Postgres, in a normal pod. In production, we go the extra step where we are using Amazon RDS. So that is where it gets a little bit more expensive, but then you don't manage a whole database backup and all of that. Does that make sense? Okay, I will assume that it makes sense. Now, there's a good question here, and that I don't know, yeah? So one of the examples, I'm always mixed on the Rust web app, is what use case should I use to make a realistic web app? The goal of Rust web app is, and the reason why I created Rust web app is because I have the same thing, and you don't have to worry about this one, but my consulting company is Bryce Snow, and we're building big apps with small team for big and small startup. I'm based in San Francisco and Silicon Valley. So we build big apps with small team. And the way that I work is I have my development team, and I always work on the blueprint. Yeah, so it's an architecture first approach, but it's not a PowerPoint architecture. It's a coder architecture, which means I spend a lot of time in my cave to code the right architectures and learn, the Kubernetes and all of that. And I came up with all of this kind of code here, yes, which is based on Node.js. And so it's the same kind of thing. So I have the front end here. I can have different front ends. There's a common part. And then we have the services, the same thing, which is some services are going to be, the Vite init and scaler. Those are examples of backend services that take the jobs. And then that is the IT, the admin web server, the IT server, and that is a web server. That is a whole example here of when you deploy that in a Node.js kind of way, you get basically this architecture that we had there. Now, in Rust here, my goal is to say, I'm a big proponent of Rust, even for, especially actually for web application and web backend. It's a very robust and efficient language. And so the point is to say, well, can I write a blueprint that does what we did for like 15 years in the Node.js? And before, by the way, it was the same architecture, but the backend was Java. So it's really much like language agnostic. So that's why now I'm saying, well, okay, let's create a Rust web app. And today it's only one server, but the goal here is to have all of these kind of servers. Yeah, so I need to find a good use case to have more servers. The one that I was leading towards is a whole chat business, because everybody's doing that right now. So at least it's common. And now goes to the right question, I think, is I'm sure that some of you have seen GenAI and these kind of things, but the question is, do we, like if someone asks a question to LLM, does the web server does the work? Or does the web server just capture what the user is asking, sending it to the right services, and the services sending it to the right services, by talking to the queue, then the service will read it from the queue, will do the processing, will add it to the queue, and then these guys will read it back from the queues to send it back to the user. So that is the right way of doing it, but it's a little bit tricky because when you do a video scaler or video whatever, it's fine that is out of sync because the user doesn't expect the response right away. In this case, the user do expect the response right away. And in fact, it's even worse because the industry, and I'm not saying the industry was wrong, but as a requirement, it's tricky. The industry and OpenAI and everything and everybody, they go to all this streaming business, where we ask a question and now rather to get, the 300 words back, we get them printed 1 by 1 or 2 by 2. And that is good for the end user because they feel something is happening rather to wait the 5 seconds, 10 seconds, or 20 seconds to get the answer back. From an architecture standpoint, it's getting tricky because then, you don't want to stream the event and do the ping pong all the time. So you probably want to have another server here that just do this kind of things a little bit. So that is where you break a little bit not break, but you're saying it's a long-lived thing, but the user is expecting a stream of data back. And therefore, it doesn't have to do the whole ping pong with backend services. Does that, I hope it makes sense. Does that make sense to everybody? Or? And we are only 2 here, so you guys can, ask your question in a way. I want to make that very personal to you guys. So if you have any further question, feel free to ask. So that is the goal. So one of the things in the Rust web app, the cool thing is what I did a couple of, good. That's perfect. So I'm going to continue here. So the end goal of the Rust web app is to do that, to actually define all of that, the same way that I did with my class starter for Node.js. And the way that it started with this guy, but as we can see, and if I don't, it's architected such as we can have more than one guy here. So that is the architecture here. The key architecture is that we can have our web server and different services over there, and that is the thing that is reused. I need to find a way to put the UI somewhere. So today, I think is there actually. But as you can see, I don't want to overwhelm people too much, but in my class starter, we had a more advanced stuff. So this was all of the UI. It was post CSS, source. That is JavaScript just because it's config file, but otherwise everything is TypeScript and TypeScript or PCSS and everything. So the point is that I need to bring that back into this to show how to do a single app. It's a lot of the design is a simple single app page. So you load the HTML and JavaScript and CSS, and then you have the whole app. It can work also with several rendered things if SEO is needed, but usually if you have a login app, single app, it's a very good fit for that requirement. And so the goal here is to add this part, and then the next big goal, which I started a little bit a while back, is to add the famous Kubernetes. And I will answer your question here. I'm just finishing this guy. Is this one here. So I don't want to go too deep on this one, but we had a whole set of YAML file. You can use Helm or whatever, but we have a set of YAML files, and you can see all the services, and that is what gets deployed locally on your Podman, on your Docker for Mac, on Amazon Kubernetes, and everything. So it's become extremely portable. And we have a way of overlaying, the file. So this layer, it's a little bit like Helm, can layer this layer. And you can use Helm, it doesn't really matter, but I've implemented a little thing which is called KDD. And you define your variables here, which is not the secret. Yeah, this is just variable stuff. And I define my overlay. So for example, .prod, KDD prod, this is only on the AWS, is one ECS that has this KDD prod with stuff and things. And that will overlay another KDD YAML on top of this one. And that will allow us to have the production environment. So now the things that you want in production and local dev is to reduce the proximity, or maximize the proximity, or whatever, however you say it, between production and dev. And that is what it allows you to do here, because now I can have my realms, which is where I deploy. And so I have a realms dev, which is I'm going to deploy locally. And then I have a realm AWS, and then I can have my prod. So this one is just comments, but I can have my prods. And block is what we build. So with these little things, you have KDD, which I rewritten in Rust as well, that runs that and just call Docker build and Kubernetes stuff. So there's no magic in a way, it's just a way to streamline the development. And then the YAML become handlebar templates. Okay? So that is a way that this beast kind of work. You can use Helm, it doesn't matter. The point is, from an architecture standpoint, is you want your local development and your production to be as close as possible. So whatever technique is being used. One of our practice have implemented a kind of application with using Azure, I'm sorry, but it's legacy on functions, Azure. Yes. Yes. Yeah. Oh, using AI, I mean. Oh, okay. So it's not Azure. Kind of application using AI, but it's legacy function Azure. Okay, so that is the way I think you meant. Yeah, the problem, and this is kind of a video that I did. I don't know if you watch it, but I did it. Stuff is the difference between server and serverless. Yeah. And that is, like, people sometimes think that is serverless is a whole new architecture and it changed, you can do your application one way or the other. And it's not true. Yeah. They both have good and bad, but they don't really replace each other. Now, can you do some stuff one way with the other way and vice versa? Yes. And some of the stuff are better done there, and some of the stuff are better done there. But in short is, you either have a long running process that gets the job and makes the job, and then you keep paying here. But the good news is this guy, you can load whatever you want. Or you can have short running process that are just awake when you have some work to do, and then you do the things. So if you do the AI, and I don't know if that was your point, but if you do your AI, like when people are asking a thing as a Lambda, yeah, it might make sense in a way, I guess. Yeah. But if you have enough traffic, so there's two things, yeah. Assuming you are not running your own model, because if you are running your own model, it doesn't make sense at all to run it in a Lambda. And the reason why, or a function, is because for Lambda to work, for us to not pay at the middle, the cloud provider is obviously shutting down the machine and anything that has been loaded. There's some exceptions sometimes, they keep it warm for a little while, but eventually, the thing would get shut down. So what we don't want is to have a model, even if it's an 8 gig model and stuff, loading it, answering one question, and then throwing away. That would be silly. So this is why usually you probably want to have to run the model. Yeah, you probably want to run this guy. And I would argue here that in the cloud, what you want is probably have a whole dedicated cluster, assuming you are not using OpenAI or Cloud or DeepSeek or whatever. Assuming you are not using Bedrock or on Azure, they have the Azure, OpenAI or whatever they have, and you want to run your own meta model or Mistral or whatever, you will have your own farm that does just that. And that doesn't have to be done it doesn't really matter because the cost of the request is not, the middleman, it's the thing behind. So you want to expose an API, hopefully an OpenAI API, perhaps with Ollama. There's also another one, which is Fireworks, I think, that stuff. So you export that in a server farm and you keep them warm because you want to have the model warm. And you try to mutualize as much as you can. Yeah, and scale up and scale down. This is a whole art here. And that shouldn't really go and mess around with your normal application. Yeah, because otherwise you're going to have weird requirements that are going to cascade into this one. And that is going to be weird. Yeah. So in a way, this kind of farm of model runner can have his own custom stuff just dedicated to run stateless LLM command. Yeah? Then the thing I was saying is to say, once you have solved that, or you are using OpenAI API or whatever, when the user is asking a request here and then you get the data from your RAG or whatever, is where do you send the request or where do you send the user to get the answer back? And that is where Lambda could be okay, perhaps, I don't know. Yeah. But if you have enough requests and stuff, having a long server runner, you can load stuff, preload stuff and things, and there's some benefits there. Yeah. The reason why I say that Lambda might be okay for that particular use case is because in the case of Lambda, you have a latency to get up, to run, and then it shut down. But because you keep very few state over there, and then it's probably requests that will go to the database and everything anyway. Then it goes back. So you have the database connection issue. But when it goes back, then you can just respond to the user. And the latency of starting the thing up might be sub-second or seconds. But it doesn't matter because the request takes so long anyway. It's a multi-second response, yeah, LLM all the time. So in proportion is okay. Yeah, so that is what I'm saying. I must say that really frustrating this way of communicating. Okay, that's fair. The goal is to analyze very simple. What do you mean? The goal is to analyze very simple documents using technologies that allow good quality and low and scalable cost. Yeah, I'm not sure I fully follow when you say, I must say that really, and it's fine, I love feedback, yeah? But when you say, I must say, that's really frustrating this way of communicating, what do you mean? The fact that I say that serverless was a bad name? I wasn't, perhaps it was misconstrued. I wasn't saying that serverless is bad. I was saying serverless is a bad name because it's server code that runs on the server and that has its own characteristic. And so I hope the video was not interpreted as serverless is not good. I was saying serverless is one of the tools of the tool belt. So is there something I'm missing on the way of communicating? Okay, so while you answer that, I can do the step. So the goal of the so now the goal of the let me go back. So that is the goal of the Rust web app, is to fit into this kind of architecture. And then eventually we're going to do all of that. And that is the example of the one that is on top. Yes, the web server. So that is the way it works. And then one thing I need to show eventually is an example of the thing. Yeah, but I'm just curious, Roberto, is what was a, and I don't take it bad, yeah? I'm just trying, what was a bad way of communication here? What did I, and again, it's not negative for me, yeah? Is where I communicated, I might have been misleading, it's on the way that I say, it's the icon, or it's a way to say serverless is bad, or what was the tone? And it's funny because when I make this video, like usually I'm trying to make video just to teach one way of doing things and it runs and stuff, so it doesn't have stuff. When we talk about architecture, it's tricky because there's a way where we need to realize that there's many good ways to do the same thing, but there's more ways to do the same thing, more bad ways to do the same thing. And it's always a judgment call, yeah, that's for sure. Yes, people can say Visual Basic is a great language for server-side. Very few people say that, yeah. There's some people that Ruby on Rails is a great, service language to do a high-scale application, yeah. I mean, the first Stripe people, Square people, and everything, the first generation over there were saying that. But then we might also differ with that and say, hey, this is not the most optimum language for that. Ruby is great perhaps for brew, homebrew on Mac, and for some of the use case, but might not be. Yeah. Roberto, I'm very interested in that. It's sad that live doesn't have voice here. The only thing I'm saying is, and there's a delay between what I ask and I think when you hear it, so this is why it takes time. But my question. Yes. And I think is the issue here why it's hard is it's because there's kind of a big delay. I fear that there's a big delay because I see myself on the YouTube studio here, which comes way later. And I think it's between your message, which is, I think, more real time. I don't know. Yeah, there's a delay on stuff. So this might be tricky. I was expecting to be a little bit more real time the chat, but I might be missing something. So again, I'm still learning on the YouTube live stuff. So anyway, that is the goal. So again, there's going to be another things in the Rust web app, which is going to be more how the job is going to work. Yeah, so it's going to be, I'm going to try to do a similar kind of drawing and showing how to do the work. So I'm trying to, again, find a good use case for the Rust web app that will have all these use cases. I liked a lot the use case of uploading a video, scaling it back and stuff, because that is long-running jobs that is useful. Yeah, I think the delay is killing us. I'm just seeing your stuff. So I think you have a better sense of the delay than me because I cannot, but I just see your message. Then I don't know if you want to know why I choose JSON-RPC, but I'm a big fan of JSON-RPC. Actually, a little bit mad at myself that I discovered JSON-RPC too late. I think it was there in 2014 or whatever, or even before. The JSON-RPC one, it was a little bit tricky because the arguments, the params were an array. JSON-RPC 2, the params can be named, which I think it's pretty important. I mean, you can support array, but I think it's nice to have named things. And I think it's a beautiful way to express what most of the application need, including CRUD. My experience in web app is we always start with CRUD and we always end with more. So the problem of having a whole thing where is tied to the protocol, yeah, the HTTP verb and all these kind of things, is that then there's so much gymnastics that as soon as you go out of the scope, it gets a little bit tricky, and there's different ways to answer the stuff. In JSON-RPC, it's trivial. It's a remote call, and then you do a remote call. The way that I like to do it now is with these things, which is the noun, the entity, underscore and the verb. And sometimes here it can be more. Yeah. So that works very well. And the RPC request is not the ID of any entity, is the ID of the request, because in JSON-RPC, there's a way where you can batch multiple requests. And so in this case, the clients need to be able to find back his duck. And so that is a way and so this is a responsibility of the client to send it. The server just echo it back. Yeah. So the only responsibility of server is to make sure that for the response of this RPC, it will make exactly the same ID. And the ID can be new, but cannot be absent. Yeah. So again, I'm a big fan of JSON-RPC. It's kind of weird that it didn't go. I think people went to JSON-RPC, which is from a technical standpoint, it looks so much more robust. But the trick is that it has a huge cost and is very intrusive in the code because it's very compile time centric and it's binary and all of that. And it's nice, I think, for some cases, but in most of the case, I think JSON. And the irony is a lot of people are using JSON-RPC because it's from the UI, it gets serialized in JSON anyway. So the whole performance benefit get lost. You just get the types. But again, if you have Rust or Java on the backend, type validation happen anyway. Yeah. So there's still a benefit of having end-to-end type, but in the Rust web app, I don't know if I have it. I think I'm in the Rust web app. I already created another app. I know I don't have it here. So I have another app which is called Awesome App. Interesting, yeah. So it's a good question here about the manage to add some function to the BMC. But what if I want some function that don't relate to specific model? This is a good question. If you have a good use case, and obviously don't talk about your specific use case, but if you can find an analog use case of what you're trying to build, that will be good. I'm going to go back to this one. I want to go back to this. There's another application, and one day probably in one of these live, I will talk about it, is, okay, there's a lot of stuff. I code way too much. But this is Awesome App, which is a reboot of the Awesome App. So I've recreated the whole thing. That it was 2024. I didn't put it open source yet. It's not because I want to hide the source. It's because it's not, there's still a lot of noise everywhere and stuff. So I want to make it cleaner. But the thing here is that I have tools, TS types. Yeah. So I have a thing here, tools that I've created. So I have a tool that I created that takes the TS type. So it's a little bit hacky, but it works pretty nicely. And tool TS type. And then I'm using, there's a cool library, JSON schema RS, JSON schema. And then I put in JSON schema, and then in Node.js or Bun.js, I have a thing that put it back in TypeScript. So basically that allows me to take all my types, okay? And that will create the TypeScript stuff. It's a little hack because you need to have a type that has all your types. Otherwise, everything gets duplicated again and again. So this is a way I found it, is you do these kind of things, and it works actually very nicely. And so I have even my RPC types like that, where I just have the RPC, and then I have my model types. And that will generate, one day I need to put that there, binding here. That is what it would generate. So it's nice. So I have agents, and then agent for create and everything. So now on the JS side, TypeScript side, I have all the types. So that is a nice way here that I've done. This is an Awesome App. I'm going to bring it at some point into the Rust web app. But that is to say that we can have type end-to-end types without JSON-RPC. It's not exactly the same, but you come pretty close. So question, this is a good question. Question is to say, what if cars and bikes, but I want to see the inventory for all vehicles? So it's funny because in this use case, so it's a very cool use case. This is cool. So you have cars and bikes. So I'm going to assume that you have a car table and a bike table, okay? And then you are going to say, I want to see the inventory for all vehicles. So this means that there's something. For me, I will create an inventory BMC. Yeah? And the trick is that to say, where inventory BMC, and this is a very good point, is that in this, so that will be my architecture stuff, to create an inventory BMC. And now the thing that comes is to say, where inventory BMC is nice, but it doesn't have an entity. Can we have a BMC without entity? And I think that that is a use case I need to make sure that it's supported. Because I think you are completely right. Yes, this is spot on. I really love that. This is awesome. I'm going to add that and probably do a video on that. So I think this is a very good use case, and I will do an inventory. And the reason why I will put it in the BMC, because you want to have all data access going through the BMC. Because in fact here, and this is critical here to understand the REST web app, and this is something that we have done in our Node.js, even Java backend. So it's very proven pattern. What the ACS, access control system, you do not put the ACS on the web layer. Do not put the ACS on the web layer. You put it on the data layer. So on the web layer, you want to do authentication to make sure that the guy that get is the right guy. And if he's not, out. The data layer is responsible to say, if you want to see the data, I'm going to check that you can access it. Okay, so there's a big discussion in there's a cool developer here. It's Igran and stuff. He created, we had some discussion about the ACS. I don't have the ACS layer, unfortunately, yet. I need to implement it. There's a lot of design in my head. It's pretty mature, but I need to spend the time to crystallize it. But the point is you put that in your model. So that is where you put the things. And so, for example, here, if we want to say, hey, conversation, we want to have the BMC, okay? We want the conversation to have some sort of privilege or whatever. So I'm going to go there. So then this is where, and actually it's cool. I got lucky here. This is the thing I wanted to show. So you will have a requires privilege any off, and you say, okay, org, this is org, I guess, org full access, SP full access. This is not well thought out, but it's to say if I want to have message kind of things, this is kind of the roles that I need to have. Yeah, I mean, not the roles, sorry, the privileges. So the goal is to be privilege-centric and not role-centric, meaning that for the end users and the setup, you allow people to set up roles on users, because otherwise it's become too complex. Yeah, you group it. But then as soon as the request come and stuff, role got expanded into privileges on organization and projects and conversation or whatever we have. And then don't focus too much on the text here, because this will change here. This one was an old one. But the point is you have these things where you have organization privilege, or you have conversation privilege or whatever, yeah? And that allows you to express, to say, which privilege do I need to have to be able to add the messages to this conversation. Yeah? And so when you put it there, it doesn't matter the web RPC stuff, is because the privilege will get started there, will get checked there. And the goal to do that is this guy here, this decorator or attribute or whatever, will add a function here, which will be ACS, check, or validate, or assert, yeah. Assert privileges, and then it will pass the CTX, will pass the model manager, and then it will pass this guy here. Yeah, so this string here will be a whole static array. So that will pass something like that. You can put it as a static stuff. And then that will be what you see there. Okay. So that will pass there. And there's more to it. Yeah, I mean, in the Discord here, there's good discussion because sometimes you want to check the org and everything, and sometimes you want to charge the entity. But basically, that is the gist of it. And that will allow us to have access privilege at the BMC content access. Yeah. And once you have that, the cool things about this architecture is that then, so hopefully I'm clear in what I'm explaining and don't. Give me a sec. Is that then we have everything in the core. Yeah. So anybody that use the core have authorization now. So that is the beauty of the thing, yeah, because now what you're saying is to say, hey, even if it's not web server, let's say I wanted to do a server for authorization. Yeah, sometimes there's architectures that say, we're going to do the authorization as a web service, which for me, I'm not a big fan of. But let's say you want to do that for whatever reason. Well, you can just take the core, put it there, expose the stuff, and then that's fine. You can expose your data API. Or you want to say, well, I don't want this architecture. I don't want to play ping pong. I want my web server to have their own stuff. It's like, yeah, it's fine. You have it. It's a library. Yeah. And then you put it in your web app, and then that's it. You have it. It's the same one as if you had it. That is authentication, is not authorization. Yeah. The two are decoupled. So this one creates the CTX. This one populates the CTX. And in the concept here that in the Rust web app is the CTX will have org privilege, will have a mutex for cache for the privilege, just as when it calls sub BMC and stuff, it doesn't have to go back to the database to check the role. Yeah, so you don't load everything, but as these guys are going to assess, you know, the ACS layer will populate the stuff. So here, there will be an inner mutability, but there will be a low contention because it's mostly in a single threaded. Yeah, I'm going to say it's a single thread. And if it's not, it doesn't break anyway. So it's fine, but it's a low contention stuff. Does that answer? Might have been a long answer here, but hopefully that was useful. Okay, yeah, okay, I have to wait here. I'm sorry. Okay, YouTube, it could have done a little bit more, better latency stuff. I don't know if what the name Twitch is faster, but I don't want to go to Twitch. I mean, I have nothing against Twitch, but I'm not set up and I have to learn and everything. But I'm a little bit surprised by the latency here. Any other? So if you have any other question, please add them. I'm going to have to learn to work with latency here. So when I'm speaking and everything, if you have any question, feel free to ask. Or even if it's not on that, there were another topics that people might be interested was the SQLX stuff that we can talk about it. But here we are close to the 1 hour mark, so I have more time. But if you guys are done, I won't take it bad. Do services also access the context? This is a good question. Okay, I'm trying to answer it right because it's recorded, I think. Yes and no. typically, services, let's say, for example, you have a video scaler. Yeah. So let's say, I'm going to take a silly example right now. Let's say that, sorry. Yeah. Let's say that you have a case here where the service one is a video scaler. So the service one is getting an event saying service two. Yeah, service two is getting an event saying this video has been uploaded and full definition, and your goal is to reduce it. Okay. In this case, honestly, you have two ways of doing it. To say, well, okay, when this guy, the trick is which user it is. Yeah. So, for example, the user here comes and say, hey, can you upload all of the videos from this box folder, Dropbox, or whatever? Well, does that mean that the upload is the user A? Might be, might not be. The problem is if you go like that, let's say that user A say, upload all of these 20 videos. And then you send an event here. So that is the way we do it. And say, hey, upload 20 video, upload this folder. Yeah. Import this folder videos. And then here's a user ID. So let's say it's Mike. And then we say, this guy is going to look at it and create all the jobs to import all the videos. And let's say that there's 20 job items now to import these videos with the Mike token or whatever we want to call it. What happens if Mike leaves the company? Does the whole thing breaks? Because now he doesn't have access. We don't want Mike out of the company to be able to import new files, that's for sure. So Mike has been removed, or Mike has been, put inactive or whatever, yeah? So now we don't want to break the whole workflow. So the trick is that, sometimes we want to think about the use case, yeah? You want to make sure that Mike can say, import this box folder at the time it does it, but the jobs themselves, not sure they belong to Mike anymore. Now, you might keep the Mike thing in the database and say that has been requested by user 123, which happened to be Mike, but you don't want to break the service if that doesn't work. Yeah, you want to keep it for traceability, perhaps, but you don't want to break it as a authentication or authorization rule. So that is the two difference where it's tricky. Like for us, most of the services on the backend, honestly, they were user-less. Yeah. Now, one good practice is to say, well, the server here can send the things, and then you still have an IT or a system user in the database, and you still have this token, such as you have the flexibility later to pass the token of someone, yeah, or whatever. That could be a good approach. But typically for me, the service, except if it's an obvious one, like for example, in our case where it's a chat app, yeah, well, it's tricky to know where we're going to do. So that needs to be authenticated because you don't want the chat to go to someone else. But otherwise, all of these guys, they are behind the VPC anyway. So the key here, those are the front service. Here, they are behind the VPC. You cannot access those from the outside world. Yeah, so that is very important. So the short answer to your question, sorry for the long one, is typically no, might be exceptions. Yeah. Now, that doesn't mean that you don't keep where does the request come from, but typically that doesn't have to be kept at the request level. It could be at the order level. Yeah, you can have a concept of an order of import and then keep it there. So I think that is stuff. If you have any other question, Roberto, and thanks. And if you guys have to go, you can let me know. We can end the stream. I'm trying to make the stream also useful for people that watch after the fact. So same thing, people that watch the thing after the fact, add comment. I'm just learning, this whole live stream kind of business. I think it's pretty cool. And I like to have, the small group dedicated users. So this is very cool. Thanks a lot. And then that's it. So that is what I'm going to do. A couple of things that I'm going to do in the next week or so. I'm going to clean up a little bit the code. I already did some some cleanup. At some point, there were librpc app. There were a pull request. I mean, it was an interesting one that split it there. I don't think it should be split at this point, at least. In a way, it's part of the responsibility of the web server, you know, the agent and the staff. So I move it back here. I updated to Axom 0.8. There were a couple of things. And also to SQLX, the latest patch, they had a breaking change, so I fixed that, hopefully. Yeah, so that was this issue. So I done that. I'm going to clean up to make sure that I follow my error best practices. I think it's pretty close, but sometimes I've seen that they were, I think, error, create error or whatever. Yeah, error.error, which now I like to have it as a root. I'm going to change I'm using SHA-512, and I'm going to change it to, what the name? Blake3 for the token. Yes, I'm going to keep Argon 2, but then Argon 2 for the password, but I'm going to use Blake3 for the hash, because Blake3 is amazing, and it's not, I mean, some people argue that it's even better than SHA-512, and it's very fast and super cool. So to come back, no, but it makes sense to have authentication web app. Yeah. So, well, when you are talking to have an authentication for web app and another for, that's a very, very good question. That's very cool. So let me explain. Yes, if you do a public APIs, if you do this is a very cool question. If your job is to do a public APIs for other people to use your stuff, okay, let me explain it. If you do a public API, so ideally, if you go to management and say, hey, great news, you know, we have APIs that is for our public guys, public API for people that talk to us in Python, and also for all our web UI who are using the same API. Management is going to be happy. I'm going to say, great, reuse, I can spell it, I can understand it, I love it. Yeah, that's basically what management does. They can spell, they can love. The problem here, it doesn't work like that. And the reason why is because, and it's not all in or all out. The reason is your web UI is going to need things that doesn't need to be public, and you don't want to make it public. So you don't want to have the burden of making it public, because once an API is public, you are a little bit kind of stuck into maintaining it, making sure that there's backward compatibility and all of that, and you don't need to do all of that. Once you do a UI, you want to make sure that the UI team to say, hey, you know, when I do, and it was a good example here, your other guy here, the inventory business. Yeah, you want to make the guy on the front end. You don't want to make them doing the join on the front end. Yeah, the web UI is saying, oh, okay, I know how to do my backend stuff, and it's going to do whatever it needs to do on the server, such as it can get back the data in the cleanest way for the web UI. But the requirement of the web UI will be more specific, and telling them, oh, you need to use the generic APIs, which is a lesser API, is not nice. So here's a trick. That will be probably one of the video, and we're getting down into production here. Here's the way I like to do it. I like to, it's going to be weird, yeah, but bear with me a sec. And if you, and you guys are very patient here, I'm pretty impressed. So, dev question. Yeah. I like Markdown. So, yeah. So what I will do is something like that. I will have an API, RPC, and our API, well, okay, I'll make it simple. I will have an API pub, okay, or like V1, because everybody, you know, they like the OpenAI stuff now. But you have API V1, and then you have RPC. okay? And then you might have API v1, and then you have login, yeah, perhaps. That would be API v1 logoff. And the reason why I don't have them in the RPC is because I like to have my RPC requiring authentication and then stuff. Sometimes there were some good use cases that say, well, sometimes I want to have some RPCs that doesn't require login. And that is a valid case as well. So then you can reorganize the thing a little bit. Now, this is a public API. So I'm assuming here you want to have public APIs such as people can call you from their Python or whatever. Yeah. So that is pretty cool. And actually, I'm sorry. Okay. Bear with me. Here it is. I'm going to go directly to the answer here. I don't know why. I'm trying to make a story of everything. Okay. So what we're going to do here is, so my recommendation, the thing we did is, we did a public API, the same thing, and that is that. And the reason why there is no login logoff is because this one will take the API key, yes? Headers, yeah, bearer or whatever you want to call it, it doesn't matter, yeah, with a token, yeah. So that it will be, in this case, they will call the things, they will get the token like we do with everything else, and then they pass their stuff there. You might want to have a API login, might be okay. And then for the web API, you have the web RPC, the web login, and the web logoff. And the thing here is, what we did, what to say? I'm trying to do good. Okay, this is the next level up. Okay, I'm going to explain why. So, and that doesn't have, could be, actually, well, I'm going to put it like that. So what we did here is like this. Public API is this one. It's very constrained. There's a full documentation. It's kind of not immutable, but we're not changing it a lot. And it's completely valid to have a V1 like this or whatever. Yeah, so whatever you want. Then after, we are splitting into, this one is a proxy to this guy. Yeah, so this guy here just is the same binding as this guy. So this way it allows you, the UI, to say, when possible, use the web public APIs. Yeah, so you can do like that. It doesn't matter the name. Yeah, you do like that. And then on the backend, yeah, and then you have web-only APIs that you hit like that. Okay. This guy here allows you to reuse as much as that without using that endpoint. And the benefit of that is that in production, when you deploy it, you can deploy this path with the Amazon Application Web Lancer in some pods, in some deployments. So it's the same server. Like for us, it was the same server. The same server was giving this and giving that. It's just a deployment. We can say, oh, this path goes to this service deployment stuff, and it can scale up to 10. And then this guy goes to anything which is /web, okay, /web like that. Anything which is /web goes to this guy, and it can scale until 40, for example. Yeah. So once you do that, is you have a little bit of the best of every world, because you can reuse as many of the public API, but you namespace them, such as a deployment. You can point them to different Kubernetes deployments, for example. And so that allows us, because sometimes when you have an app, things that happen to us, yeah, you have an app and then crazy API people does a for loop, yeah, but user cannot really do a for loop. Otherwise they get very seasick, yeah. So the trick is public APIs can do for loop, users don't do for loop. So those guys will get less crazy, except if you get hacked, but that is another issue, than those guys. Those guys can have a bug here in a for loop. So you don't want those guys to take those guys down. So that's why I like to split the two. And then you want to make sure that you have your own web RPCs that doesn't need to be public. And then it's just the web UI team that has the freedom to do whatever they want, whatever makes sense for them. But at the same point, you still want to reuse the public RPC when you can, because that does make the RPC better. So with the delay, I hope that that answers your question. It's crazy there even. Yeah, I can see it in that screen. It's funny. Okay, so yeah, I see what you mean. It's the delay is killing us, but I will learn. Yeah, I mean, it's there's some live streamers that manage to do it, so I need to learn, be better at it. And then that's it. So I think that was a good session. I mean, I have more time, but I don't want to bug people too much. Yeah, well, for the health check, for me, it's not really, honestly, for the health check, I wouldn't put it as an RPC. I will have perhaps, yeah. But for me, health check is almost not even an API. Yes, it's internal, whatever. You know, it's ops or whatever. Yeah, but you can call it API. It doesn't matter. But my point is that is another endpoint, and it does whatever it has to do. But it's, you know, it's infrastructure stuff. Yeah. And it's very important. Yeah. So that is one thing that I didn't do in my stuff, and eventually health check is super important. So that's it. So I think we did a pretty good overview. If people are watching that and they haven't been in the live, please add comment to see if that was a good format, if it was too long. So one thing I don't know, Roberto and Davizer, I don't know if I pronounce correctly, is should I put this live as is, accessible to others? Because they tend to be very long, and you know, sometimes I go and ramble. So I like to edit a lot, but perhaps sometimes that is not needed for this format. So I'm going to let you tell me what I should do, and I will follow you on this one, at least for this time, and then I might revise later. So do you think I should put the live as is, accessible to everybody, and then I don't do the edit? Or do you think I should go and edit it and put it in a playlist, accessible to, you know, members only, obviously, but taking it, not putting it on the live? Yeah, I think the thing I need to learn is, when I ask a question on staff, is to not wait for the answer, because the latency of YouTube is killing us, as you were saying. Okay, so I think this is hopefully pretty good. Okay, so thanks a lot, Roberto and Davizer, for coming. For members accessible, fully created session as a full video. I'm sorry, this delay is crazy. When you say fully created, I mean, I can okay, so I don't want to spend too much time, because people. So thanks for everybody. Feel free to add comments. So I'm going to put this video live, and Davizer and Roberto, feel free to add comment on. Yeah, but either I put the video, like when you say structure by question you collected ahead, so that for future video. But like, if I do a video live, do I put it live like this as is, and then I let people kind of scan through it? Or is it better if I try to edit it to have the good parts of it? Yeah, so that is the thing I'm still unsure. But for now, I'm going to put this one as is, and then we'll see how it goes. So thanks a lot. This was very cool feedback, and we'll probably have another one kind of next week or the week after. I might do some public one as well, just to test, like a 30-minute, like just to try it out and get more familiar with it, such as I can learn with the public. And then I will organize another one. I will do the poll. And then within the poll below, feel free to add more topics and question you want. So that is awesome. And I'm going to work as well on the Rust web app. So, you know, until people want to change subject, I think the Rust web app will be a good one for this live production coding. Okay, thanks a lot, and talk to you next time. So I don't know if I should wait now that the delay or not. Ah, yeah, yes. So I will do them on Wednesday, and try to do morning, but tricky because it's when clients meeting. Yeah, so that's my challenge. My challenge is my clients meeting usually are the morning. And so I know that noon is relatively free. Otherwise, it's tricky. Okay, bye, and talk to you, both of you later. And thanks a lot for joining. I really appreciate it. Thank you.